who's the next? The next paper is watermark-based recovery of tamper documents.
For counseling. This is online. First, I will introduce the work, and then I tell you what is about spamming botnet. Because spamming botnet do many things, and it delivers a lot of spams. So we talk about that. And the EigenBot, we propose mechanics and the analysis and conclusions. Actually, botnet performs denial of service and the spam or something like fast blocks. So the most critical things also have the stale data and so on. So this is quite difficult to find because we could not find the whole botnet because it's propagated underground to the communication server. So another one is the most difficulties is botnet master. So what we want to do, not directly capture the control the command server or not directly capture the botnet master. We just want to, through the botnet text to analysis, maybe they would exist as somewhere. Okay, so this is the picture that you know the botnet master will communicate with CNC server and then communicate with the command to the spamming bot. And try to use SMTP, Open Relay, or proxy to deliver the significant number of spam. So, and last year, the semantics reports there are top 10 spamming bots in the world like this. Actually, this bot is come with different topics to deliver the spam content intentions. So, so according to this feature, we find botnet are smart enough to create a spam message, but address a lot of different recipients. So, so this work, the problem definition for this work is we want to give a spamming emails, which contains source IP and the subject, only these two informations, and some emails has been labeled by the information security expert. How we want to find the following three things. The first thing is the class of bots, because we want to know which bot do deliver some kind of information, and another one maybe selling the medicine or some drugs and so on. Also, we want to identify the given botnet and the botnet group which they belong. And finally, we want to find the outlier. Why? Because sometimes we collect a lot of data and the new botnet is coming, but they try to deliver quite different topics. So we want to spot this kind of botnet. Okay, why we have this? We preview of result. So what is our result? We want to plot this kind of things. The financial kind of botnet is at this part, and the adult is at this line, and the copycat, for example, selling the LV specs, is at the laptop side. So this is what we want to result. So because we operate systems to help the Taiwan government to find out how many botnet is around the world, around Taiwan or around the world. So we construct a system naming the honey spam. Actually, this system is doing these things. This is the bot master and the CNC server. They control many bots, and the bots try to find the relay server. So so our system is performed as an open relay server, but we do some things. For example, we do the pattern match. We want to filter some subject. It's like a probing email. What is probing email? It's want to test this open relay is transparency or not. So they have some format or some kind of title. For example, they try to use some word and given the following the IP address, and want to send another email account. This email account also held by the bot masters, and after the bot master receive this email from this open relay, they make sure that okay, this open relay is live, and they try to send a lot of spams through this open relay to the another account. However, we want to operate this kind of mechanism is not easy, because the spammers is smart. They try to test your open relays every day, and they try to use different kind of size, format, or some different titles to try to test this open relay. So how we do the pattern match is another important reason when we want to capture the attract the spammers send spam through our open relay. Actually, now we operate 4 stable mechanisms in Taiwan. The 2 has for allocate in the deployment at the Taiwan's ISP, 2 largest ISP, and another 2 mechanisms deployed at 2 universities in Taiwan. So, we deployed since August 2010, and now we collect 60 million spams and 30,000 IPs. Also, all of these spams, the content is with large are Chinese and other is English. And 1 million per day incoming now. So the motivation is we want to discriminate different botnet only from address and the content. How we do that, and the trace and the profiling the botnet behavior. So we encounter some challenges. The first challenge is the security algorithm problem. How we continuously interact with the botnet. Okay, that I just mentioned, but this is another topic, so I do not to mention the details. Maybe we can talk later offline. And another one thing is natural language processing and the SMT decoding. Actually, because this mechanism want to communicate with the botnet through the SMTP protocol. So, for example, the QP code and the base 64 is we need to decode it and dynamically to decode it to find the content. Another thing is we want to mining and do the mining and analysis, finding how many botnet groups. For example, they are unknown members groups, so we don't know now the 1 million spans how many groups it belongs. So we need to use some automatic method to identify how many groups in this data. Also, we want to extracting the latent behavior. We use latent semantic index techniques. However, the spans, the content is not so much. It's very sparse. So it's short and sparse. So we need to use some method to overcome these things. Also, we want to encounter the group of botnet. We made following 3 contributions I mentioned first. The first one, we can distinguish between distinct proposals of the botnet members. And also, we can tolerate the garbled content. The garbled content is the hackers, the spammers know you are now sniffer them, and they try to use dictionaries attacks or some redundant word to make your analysis mechanisms fail. Another is scalability, because one day the incoming spans is up to million. So we need quickly and light method to analysis. And also we want to provide a user-friendly interface to let the user know, oh, today's snapshot is like these things. The garbled content, for example, is like this one. And actually, we do some correct analysis. We found this is uniform distribution. So uniform, this is not, this is uniform. So it is random. So it's a difficult bonded. So you will see later that our output is different group of bonded. And the first thing we need to do is spend syntactic preprocessing. And the second thing is we want to do the semantic host graph contracting. We want to construct the semantic graph and for the analysis, further analysis. And then we need to identify how many intentions in this data, how many groups. Finally, we use latent span intention discovery to discover the intent behavior. This is the input. For example, the IP and then, for example, chip, Viagra, okay, or other things. So we want to use this as it's just another critical point component in our studies. But however, we do the decoding and the natural languages preprocessing. So because we got a lot of Chinese words, so we use CKIP as our sentence segment mechanisms to transfer them as a vector presentations. And finally, we do the indexing. Because the data is large, so we put into the Lucent. Okay, that is the figures. You can see the SMTP headers. We extract the source IP. Someone asked me why do not trace the MIME's IP address, because it's not correct. It can be forged by the spammers. Maybe this is not correct. So you cannot extract the MIME anything. Or I just believe the coding. How the codings they would mention here. And because here coding is for your mail server, your mail client. So your mail client is according this coding to transfer the content as you understand the coding type. So I trust it. And finally, we extract the subject and body. And then the bonnet tries to deliver span, and this span include different kind of terms. So we try to transfer this tripartite graph and to this bipartite graph. How we do that? So according to IP, we summarize this. Spans language models belong to the specified IP address. So it's like this one. For example, this is a matrix. The matrix includes this span 1, span 2, and span 3. And the term is Viagra, debit, video, and so on. So we try to, we use a seed value, is a kind variant for the TF-IDF, and can tolerate some problem from the TF-IDF. And we give the terms as a weight. And we summarize this terms weight as a summary weight, and then we put this weight and to summarize this weight and transfer this to the IPT matrix. This IPT matrix is IP to terms, and we use this IPT matrix. We can do the further analysis. We can clustering them. We can clustering them according to the IP address. This IP address is represent the specified bonnet. And how many intentions are inside? So we want to find how many the intentions numbers. The method we use we use SVD. Also we can do better than use ICA, but currently in this findings method we use SVD, and you can see the IPT has a IP to terms, and we do the decomposition, and then we found the S matrix is we can, according to select the top L concept that covers the 95% of total spectral energies, that the number of hidden variables. Actually, in this work, we found 3 to 5 concept is the most appropriate for this work. And later we do some practical analysis. Also, we can use we want to find the latent behavior. Actually, we also can use the SVD decomposition to find the latent behavior. However, we use SVD, we encounter a problem because it's too sparse. So we use SVD, the result, they are not very clear cut. So then we use ICA. The ICA result looks better. The ICA, we can decompose the IPT to the hidden variable matrix and the best matrix. And we can use hidden variable matrix we can use this as the critical concept and do the clustering classification, and we found the outlier by the H matrix. The data set is from the 4 honey spans collectors, and actually these 4 honey span collectors only have less than 5% overlapped IPs among the honey spans. And the period is from the 2010 December to June 2011 June. And actually in this data set we found 2 scenarios. The first scenario is very regular. The spammers do not know we are observe them. So they try to regular spamming body operation behavior, clear grouping from different IP sources. In another scenario, after the 2011 May, they found someone is interacting with them, and they try to deliver some garbled and dictionary attacks. This kind of dictionary attacks is like the Chinese dictionary's word, and the length are 2 or 3. And for example, this group of attack is concentrated on the chemical. Another is focused on the computer science, and the other things is focused on some physical things. So we read this data, we know that is from dictionary. So it makes our analysis more difficult. So from in the scenario 1, so we use accuracy and the precision for our measurement. And true positive means the number of spanning source hosts with a given intention category that are correctly detected. Actually, our securities analyzers try to do one-by-one label for each IPs and check these IPs belong what kind of spams. For example, we see the IPs, where is the IP from, and if this IP is located at Taiwan, we try to have a ticket to the government, and we go to the ISP to check that notebook or that PC, and we take it back and do the DD in the Linux, and we copy the disk and find what is the malware inside. So this labeling thing is might a little tricky, but it's difficult. So we do that, and we compare some baseline approaches. We found our EigenBot improved more than 10% than other baseline approach. For example, we only use SVD that perform very poor, and we use ISOMAP. It's a kind of dimension induction techniques. Actually, it's not performed very well, and the ISOMAP require a lot of computations. And then we use IPT plus SVN is not performed. Already use the IPT matrix come with the support vector machines. Also, it did not have a good performance. Okay, and also, so our result can give a very clear path from the visualization. And then this is another 2 mechanisms. The left hand is the that is from the different view, because we can extract the, for example, use ICP to have a dimension induction. We have 3 dimensions. So we, according to the different site, this is 1 and 2 and 3 and 2. We can observe different behavior of the spamming bundle. Okay, that is I just mentioned the isomap performs not quite well, but better than SVA only, but also that's not good. Also, we try to analyze the stabilities of the stability for the result, the effectiveness of the automatic finding the numbers of the intentions. So we found the better intention is at 3 for this data set. And also, we use 3 as a good performance. The finally, I want to give a case study. In the 2012, we found we receiving a type 1 probing email that is non-garbled. And then we try to interact with type 1 spamming bundle. We send the probing email to this account. And then they receive, and then we're receiving the type 2's probing emails. And also we also continue, that is what we do, that is what the spammer do. And we try to interact with type 2 spamming bundle. Also, we continue to interact with them. And we receive the mass spam emails. And the spamming, actually we found, okay, now the spamming slowed down. Finally, the EigenBot invoked the analysis. Actually, in that time, the EigenBot do the analysis, the result is like these pictures. You know how we explain these pictures. For example, in this part is from the general case. So maybe they try to send some. This is the garble. This is garble. A lot of garble is distributed. And this point, this blue plot, each plot is represent the IP. So this plot is a behavior that tries to send the dictionary of text. And this point is a long-term adult advertisement, for example, the adult video or something like that. That is not involved these two session behavior, but I don't know why this part is another new spamming behavior. So we can use this plot to find the grouping of the bundle. Okay, the conclusion. We propose that EigenBot is a kind of analysis toolkit and assistance to help the information security analyzers to find the bundle behaviors, especially in the spamming behaviors. So we give the following three contributions. We can grouping them. We can provide clear visualization. Also, we can identify the outlier for the further inspection. That is my presentation.